Hey, welcome to this explainer. If you walk onto a rig floor, I guarantee you're going to hear the word bushing probably 20 times in an hour. And honestly, at first, it just sounds like this impenetrable wall of jargon. But if you think it's just industry slang meant to confuse you, think again. Today, we are decoding the brilliantly simple concept behind this tool, and we'll see exactly how it prevents literally millions of dollars in catastrophic damage. So let's get right into it.
Seriously, spend just 1 hour on a drilling rig, and you will hear someone yell for the master bushing. Then, a few minutes later, they'll mention the Kelly bushing. Next thing you know, they're talking about a wear bushing or a casing bushing, maybe a drive bushing. It sounds like 5 completely different, highly technical tools, right? Well, it isn't. Every single one of those terms actually traces back to one incredibly simple, elegant idea. And once you grasp this one core concept, all 5 of these names are going to make sense to you instantly. You'll realize they're all doing the exact same fundamental job.
Okay, so let's dive into this. What actually is it? At its most basic level, a bushing is simply a removable liner. It's a sleeve. Its entire function is to drop into an existing opening to either limit the size of that opening, change its shape, or serve as a guide for other moving components. That's literally it. Just imagine you've got a massive hole in a heavy steel plate. You drop a specifically shaped insert into it, and boom, that hole is suddenly smaller. Or maybe it's uniquely shaped to grip a specific tool, or perfectly sized to transmit torque. But the absolute key word here, the thing you have to remember, is removable. By being a removable insert, a bushing resizes, reshapes, and guides, which allows one single piece of expensive machinery to adapt to multiple situations without needing to be fundamentally rebuilt.
Now, look at the underlying engineering genius of this. In the physical world, wear is just inevitable. Anywhere that 2 parts rub together under pressure, friction is created, and something has to wear down. You can't beat the laws of physics, right? But here's where engineers get incredibly clever. They get to choose where that wear happens. By placing a sacrificial sleeve, our bushing, right between those 2 moving parts, all that friction and wear is transferred entirely onto the insert. You are literally making a calculated design decision to control exactly where the damage happens. It's a deliberate sacrifice designed to protect the much larger, more critical system from taking the abuse. Actually, it's the exact same logic we talked about with the bit sub back in episode 13. Wear is inevitable, sure, but where it happens, that is a design decision.
Think about what happens when you don't control where the wear happens. You end up with heavy, highly expensive machinery, like your massive rotary table or your critical wellhead, taking the absolute brunt of that friction. And when those inevitably wear out, well, you're looking at days of downtime, incredible expense, and major operational headaches just to replace them. But if you use a bushing, all that wear goes into a relatively cheap, sacrificial part. When the bushing finally wears out, you don't have to take the whole rig offline for days. No, you just bring in a crane, lift out the worn bushing, drop a brand new one in, and you are back up and running in maybe 15 minutes. It is a massive, massive win for efficiency and cost saving.
To really put this into perspective, think of a standard socket set, like the one you probably have sitting in your garage right now. You own one expensive ratchet handle, and you have a whole tray of cheap, interchangeable sockets. The ratchet itself never changes, right? You just click on whichever socket perfectly matches the bolt you're trying to turn. Well, a rotary table on a rig is exactly like that ratchet, and the bushings are the sockets. This is exactly why a single rig can drill completely different sized holes using the exact same rotary table. The main machine doesn't change size at all, the inserts do. It's just such a brilliant modular approach to heavy industry. So let's untangle those 5 names from earlier using this exact principle. First up, the master bushing. That sits right in the rotary table. It's the big one that holds the slips and transmits the drive. Then you have the Kelly bushing, which sits directly inside that master bushing, specifically designed to grip the Kelly. Down in the wellhead, you'll find the wear bushing. Its entire job is purely to protect the precision sealing surfaces from the drill string grinding against them. And finally, the casing bushing simply adapts the rotary table opening to fit a different size of pipe. So that's 4 completely different locations, 4 very specific tasks, but it is the exact same foundational principle at work in every single instance.
Okay, let's look at how this builds into operational safety, because this is where the theory hits a very high-stakes reality. There is an absolute golden rule when it comes to these inserts, particularly when we're dealing with slips that hold hundreds of thousands of pounds of hanging drill pipe. The rule is this: the taper of the bushing's bowl must perfectly match the taper of the slips. These components are meticulously machined to fit together totally flush. They are matched to specific pipe sizes and specific slip types. If you try to mix and match them, or if you ignore the taper angle, Well, you aren't just being inefficient. You are creating a massive, silent safety hazard right beneath your feet on the rig floor.
Here is the terrifying domino effect of what happens when that simple golden rule gets ignored. We actually call it the silent disaster, mainly because the failure is totally underestimated right up until the exact moment it's too late. If those tapers are mismatched, or even if the bowl was just badly worn, the teeth of the slips only make contact with the pipe along a tiny fraction of their intended length. So instead of spreading all those hundreds of thousands of pounds of load evenly, all that extreme force concentrates on one tiny area. First, it crushes and deeply marks the pipe, and in the absolute worst-case scenario, the grip fails completely, the string slides right through the slips, and you just dropped thousands of feet of pipe straight down the hole. It's a catastrophic multi-million-dollar loss, all born from a simple mismatch.
And you know, there's also a quieter but incredibly expensive version of this failure down in the wellhead. Let's talk about that wear bushing again for a second. Sometimes, in a rush, a crew might forget to install the wear bushing during drilling operations. When that happens, the turning drill string continuously rubs against the exposed, precision-machined sealing surfaces of the wellhead. Over hours and days, that pipe basically acts like a giant steel file, cutting deep, deep grooves into the steel. Eventually, when you desperately need the blowout preventer to seal against those surfaces in an emergency, it can't. The seals fail. So, leaving out a simple $10,000 sacrificial insert quietly turns into a massive operation where you literally have to cut the well open and completely change out the wellhead. It's an easily preventable nightmare.
Now, I want to throw a crucial question your way, and it's one that really forces you to think like an engineer. We know the spinning drill string is the thing actually doing the damage, right? So why isn't the wear protection attached to the drill string itself? Why do we put the wear bushing down inside the wellhead? Just think about that for a second. The string is moving, the string is the active agent of friction. Yet we leave the string completely bare and we armor the stationary hole it passes through. Why on earth would we design it that way?
And here is the powerful conceptual payoff. You protect what you can't replace. The wellhead is stationary, it's incredibly expensive, and it is permanently attached to the well. You cannot easily swap out those precision sealing surfaces without a massive, complex intervention. The drill string, on the other hand, that's just pipe. If a joint of pipe gets worn, you literally just unscrew it, toss it on the rack, and grab another one. So you place your sacrificial bushing on the irreplaceable side. This brilliant engineering maxim doesn't just explain the wear bushing. It honestly explains about half the equipment on the rig. Sacrificial design is all about choosing your battles and making sure the parts you lose are the ones you can actually afford to replace. So next time you see a machine with replaceable inserts, ask yourself, what irreplaceable part is this truly protecting?